Now let's revisit the assumptions that we made before we started developing the EOQ formula. So some of these assumptions seem to be quite uh, unreasonable, so to speak. But it so happens that EOQ formula is what one would call as robust formula. Robust formula means that it gives you very good answers even if some of the assumptions are not right. Okay, they are off, but still the formula performs really very well. And the reason for that is that this part of the total cost curve is pretty flat. So even if we are off, if the actual optimal order quantity is actually that, but because of some of the assumptions being wrong, we ended up here. So the increase in cost that we are now having to pay because of the wrong assumptions is very minimal. Okay, let's look at that with an example. Okay, so here the example that we worked on was this, right? 1,000 demand, $10 cost, ordering cost, 50 cents holding cost, and we got an EOQ of 200. Okay, suppose instead of 1,000, the demand rate was actually 500. Okay, so that's quite a bit of being off. You know, it's just half of what we assumed, right? So we're going to we didn't realize that, so we thought that the order quantity is going to be 1,000, so we would still be ordering at the rate of 200. So now our inventory carrying cost is going to be, okay, I'm going to absolute reference that, Q over 2 times C sub H, okay, and I will absolute reference that as well. Okay, so that is our holding cost plus our ordering cost is going to be, so now instead of 1,000, at the end of the year the annual demand turned out to be only 500, right? So our number of orders is going to be 500 divided by the EOQ of, well, not EOQ, the order quantity of 200 that we were simply using, assuming the annual demand is going to be 1,000, okay, times C sub O, absolute reference that as well. So now that is going to be the cost. Okay, so another, suppose if it was 1,500 instead of 1,000, it turned out to be 1,500. Now instead of 1,000, it turned out to be 2,000. Okay. Now the actual cost would turn out to be, since I set it up with proper absolute references, we can copy this. So these will be the costs. But actually what would have been, suppose if we had properly assumed the correct demand, then our real EOQ would have been square root of 2 times D times the ordering cost, okay, I'll absolute reference that, divided by the holding cost, and I'll absolute reference that also. So that would have been our real EOQ. Okay, so copy. So these would have been the best EOQs, but we simply ordered at the rate of 200 because we assumed 1,000 would be the demand. Okay, so now what would be the least? If we had ordered, okay, 141 in this case or 245 in this case, what would have been the least cost? Okay, again, that would be Q over 2 times the holding cost, and I'll absolute reference that, plus D over Q. So now the demand is demand is that demand divided by Q, okay, times ordering cost. Ordering cost, I'll absolute reference that. So that would have been the least cost. So what is the difference? How much is the change? So let's see. The actual cost minus the least cost divided by the least cost. So, and that's a percentage. So I'll change it to percent. So you see that it is very small. The actual difference in percentage terms is very small. And we can do similar sensitivity analysis for the other two parameters here, ordering cost and holding cost. We can set up a table and keep those costs variable and see what happens to the total cost, how much deviation we end up with when we do not properly estimate these costs. Now sometimes, as I mentioned previously, holding cost may be expressed as a percentage of cost of the item, because the cost of capital is the most important or most significant part of carrying cost, and that would be directly proportional to the cost of the item. So sometimes instead of the C sub h being given as a dollar amount, it will be given as a percentage. So annual holding charge as a percentage of unit cost or unit price. So in that case, we have to first compute what C sub h is. So C sub h in that case will be the percentage I times the cost of the item, and then use that in the EOQ formula. Now, one more aspect for sensitivity analysis is to see how much change for the quantity itself will be. Instead of looking at the cost, we can look at the value of Q. So because of the square root that we have, the change is moderated. So here, for example, increase C sub O by 4 times, right? From $10, you go to $40. But EOQ goes up only by twice because of the square root.